Are there any questions over any of the assignments thus far? So over 8.1 or 8.2?
No, sir.
Now what we're looking at today is showing that two triangles are similar by side-side-side similarity. Now we're not saying that their side lengths are going to be congruent, but the side lengths are going to be proportional. So if we divide the side lengths and get the same proportion, then they're going to be similar.
Can we call this the snake theory? Snake
Theory?
snake theory?
You can call it the snake theory.
Yes.
So when we look at this here, we're comparing the side lengths to each other. And if they are all the same fraction, they're all the same scale, then we can say the two triangles are similar to each other. So the first one we're looking at here, we want to determine is either triangle DEF or triangle GHJ similar to triangle ABC. So we're comparing these two triangles here to triangle ABC. And when we compare the sides, if we get the same fraction, then they're going to be similar. So for triangle ABC, well, we can start with side length AB. Now, which one of these two do we think is going to be similar? DEF. So what side is going to be matched up with side length AB? DE. Because if we look at AB, AB has a length of 8, yes? Is 8 the smallest, middle, or biggest side? Smallest, yes? So in the other triangles, it will match up with the side length that is the smallest. Because if they're going to scale, the smallest should stay the smallest overall, and the biggest should stay the biggest. Because if we're scaling them, they're all going to scale up or down at the same amount. So the smallest side should stay the smallest. And what we're saying here is AB, which is 8, is going to be over 6. And now we will reduce the fraction down so that we can make sure that the side lengths are comparing to be the same. This will reduce to 4/3. So we looked at AB, we can look at AC next. AC is the biggest side length, yes? So in DEF, the biggest side length is DF. Now what that would give us is and 16 over 12 would reduce to, because 16 and 12 both have a common factor of 4. So that looks good so far because we have two that are the same, because both of these do scale down to 4/3. But we have to have all three. We only have 2 at the moment. Yes, we need to check all 3 because it could work out that the third one isn't. So the last side we haven't looked at is BC, and BC is going to be over EF. Now, guys, the side length for BC is 12, and the side length for EF is so since these do have all 3 of the same proportions, we can say that triangle ABC is similar to triangle DEF. Because the proportion for all 3 sets of sides is the same. So the 2 triangles are going to be similar. Right, and there's sometimes we can see it a little bit easier than others, depending on the numbers and how they look. Now, if we compared the other 2, let's see here. I'm going to erase this here so I have room to write. Well, the biggest side length for AC is 16. the biggest side length for GHJ is? Well, 16 divided by 16 is 1. Now, the smallest side length for ABC is, and the smallest side length for GHJ is? Well, those do both give us the same measure, yes? But again, we still need to do all 3 sets. And the middle side length for ABC is, and for GHJ is, this here is not equal to 1. So even though we do get 2, it's not similar because the third one isn't the same. We need all 3 to have the same proportion. So the 2 that are similar for this here are A, B, C, and D, E, F. Questions on this here? Is either PQR or triangle STU similar to triangle VWX? Well, we know one of the 2 triangles is going to be similar to VWX because, well, the directions told us that. So we're trying to see which one it is. Okay, we can do that one first. So we can compare STU and VWX to each other. Now, what is one of the side lengths for one of these 2 triangles? 8. So we'll put VXW on top. Now, if we pick one to go on top, it needs to stay on top for the rest of them so that we can guarantee that the fractions will reduce the same way. Now, what side matches up with our 8? Now, we can go on and reduce 8 over 20. They do have a common factor of 4, which would reduce to 2 over 5, yes. Two over 5. What's our next set of sides that we're going to compare for this? So we can do 8 over 20 again, which is 2/5. So we've done both of the 8s and we've done both of the 20s. What does that leave us with? 12 over 30, which is our last set of sides, yes? Now we can plug this in the calculator, figure this out, and see what it reduces to.
It'd be 2 over 5.
Common factor of 6. Well, all 3 of these here are the same. So VWX is similar to UTS or STU. Either way works. Because of the 2 sides that are congruent.
How about TSU?
TSU wouldn't work because we're going along the side with 20 and then the side with 30. So one of the congruents in the other, because here we're going VWX 8, 8, 12. So we would go congruent, same, biggest. So here we need to go same, biggest, or 20, 20, 30. They need to go in the same order. Any other questions on this here? And the other one wouldn't work. And if we looked at that there, because we could say 8 over 12, which would reduce to 2/3. And our 12 over 16 would reduce to 3/4. Since those 2 are not the exact same, we can't say that those 2 triangles are similar. Any questions on this here? All right, let's look at the next one here. Which of these 3 triangles are similar? So 2 of them are similar to each other. We've got to figure out which ones because they didn't tell us anything this time. So we can pick 2 of these triangles to try first and then go from there. Okay, so we'll look at XYZ and RST or RTS. Now looking at these 2 here, we need to pick one side from one of them to go on top. Which one do we want? RS, which is 24. Now on the triangle, is 24 the smallest, biggest, or in the middle? smallest. So for XYZ, which side is the smallest? ZY, which is 30. So we need to compare 24 over 30, which 2 will go into both, but 6 will. 6 will go into both of these here. Have a good weekend. So we get 4 over 5. Now we can look at the next one. So we need another side from RST. RT, so we can do 30. Now is 30 the smallest, biggest, or middle? It's in the middle. So what side from XYZ is in the middle? 36. Well, again, 30 and 36 are both divisible by 6. So this here is telling us that this is not going to work because these are not the same. And if we looked at the last one, it would have been 33 over 39, which is 11 over 13. Okay, none of them have the same scale. So XYZ and RTS, RST, STR, these two are not similar. Which two do we want to try next? LMN and RTS. We can try these two next. So if we look at these two here, we can do the smallest sides first. So the smallest side for MLN is 20. So 20 would be the smallest, and the smallest for RST would be 24. And we can reduce 20 over 24 because they're both divisible by 4 over 5. 5 over 6. Because it is divisible by 4 for both. 5 goes into 24 times, and 6 goes into 24 4 times. Now the next set of sides we can pick is 24, because that's the middle length for LMN, and the middle length for RST is 30. And if we reduce this here, 6 goes into both 24 and 30. 6 goes into 24. 4 over 5, yes. That's 4 over 5. Well, those aren't the same. XYZ. So let's compare those two. Well, we can start off with the smallest again, 20. And the smallest side for XYZ is 30. And 20 over 30 is 2/3. That's not too bad to simplify. Now the next one we can look at is the middle sides, which would have been which will be well, both of these are divisible by 12. 24 divided by 12 is 2 over 3. So this is promising because it's the first one that's worked for the first two. And the last set of sides is, well, this one here has a common factor of 13. So this one here, they do work for all three, which tells us that triangle LMN, because I just picked LMN. So let's see here. So I went LMN. Well, L to M, 20 is the smallest, yes? 24 is the middle, and then we have the biggest, yes? In the other triangle, the smallest is 30. The middle is 36 and the biggest is 39, yes? So I went along the smallest, middle, biggest. So smallest, middle, so Y. So we can also use the side links to figure out how they connect. Any questions on this here? Find the value of x that makes ABC similar to DEF. So again, for them to be similar, their proportions have to be the same, yes? Three times x plus 1? We could if they were congruent. But we know that ABC, if we scale it up, and it should be scaled up, we would get to our other triangle DEF, yes? So we can't just set them equal, but we are going to set two fractions equal to each other, because again, when we scale them up or down, the scale factor will be the same. Now, A, B, C, D, E, F. So, let's get a highlighter. Our AB and ED are corresponding. BC and EF are corresponding, and FD and AC are corresponding to each other. Now, looking at all these here, which two sides that correspond are just numbers? 4 and 12, yes? If it was me, that would be one of the fractions I'm going to use. Because I would try to avoid using the two that I highlighted in green and the two in purple. Because if we do that, we can still solve it, but how many times does x appear if we use that setup? Twice, because we have it one for the purple and one for the green. If I can avoid using it twice, it makes it a little bit easier to solve. Well, we can use the side that has x minus 1. And what does it compare to? 18, yes? Now a side that a part of the triangle with x minus 1 is? This here is going to be a little bit easier to work. Now at this point here, we can multiply both sides by 18. Because here the 18 and 18 will cancel out, telling me that x minus 1 is equal to 4 over 12 times 18. Now if we typed all that into the calculator, yep, it would erase. Because if we typed this whole thing into the calculator, we would get 6. Well, 4 over 12 is 1/3, and 1/3 of 18 would be 6. Yes. Now, exactly. Because here is x by itself? Well, no. So we have to add 1 to both sides, telling us x is equal to 7. So when x is 7, these two triangles are going to be proportional. They're going to be proportional to each other. Any questions on this here? Now we could plug it back in. This here, 7 minus 1 would be 6. Here we can say 3 times 7 plus 1. Well, 7 plus 1 is 8, and 3 times 8 is 24. So this side length here would be 24. Well, 4 times what is 12? 6 times 3 is 8 times 3 is? Yeah. So it does work. If we notice that multiplication of 3, well, we could say what times 3 is 18? Well, 6, yes? So x minus 1 needs to equal 6 because that's what the side length should be, and we can solve for x that way. Any questions on any of this here?